we want to take a look at a particular arrangement of the sequence called the arithmetical progression. I want you to note that another word for arithmetical progression is linear sequence. That is another name given to it. So let's delve deeper into linear sequence and see what linear sequence is. Now, arithmetic progression, also referred to as AP or linear sequence, is a sequence in which the terms are arranged such that a constant number is added to any of the terms to produce the next term. This means that the terms in the arithmetical progression differ from each other by a constant number, also called the common difference, which has the symbol D. In an arithmetic progression, the common difference added to the first term will give the second term. Also, the common difference added to the second term will produce the third term, and so on. Another name for arithmetical progression is what we call the linear sequence. The consecutive terms of an AP will always increase and decrease by a constant number. The constant number is a common difference. Please note that the common difference can be a negative or a positive number. Some examples of arithmetical progression are I, 2, 5, 8, 11, 14, 17. I, 1, 5, 9, 13. I, 1, 3, 5, 7, 9. Ivan, 7, 6 whole number 1 over 4, 5 whole number 1 over 2, and so on. Vane, 2, 4, 6, 8, 10, and so on. VI, 3, 6, 9, 12, 15, and so on. VII, we have 3 whole number 1 over 2, 4 whole number 1 over 2, 5 whole number 1 over 2, 6 whole number 1 over 2, and so on. So these are examples of arithmetical progression called AP or linear sequence. Now, at this point in our sequence, we want to take a look at the terms of an arithmetical progression. As we started with the sequence, we realized that an arithmetical progression is a type of sequence in which a term is ahead of another by adding or subtracting of a constant number called the common difference. Now that we have seen that, we want to now get all the terms of the arithmetical progression. Now, to do this, every arithmetical progression has a first term whose symbol is given as A. So the symbol of the first term is given as A. The common difference of all arithmetical progression also has a symbol D. So then, the symbol of the nth term or the general term in the arithmetical progression is given as UN. So UN becomes the symbol of the nth term. And the nth term is just the general term, or probably the one that is at the last or the end of the arithmetical progression. Now, these are symbols and formula for the UN, which is equal to A plus n minus 1 times D, also referred to as the nth term. So when we are trying to say that the nth term of the arithmetical progression or the unknown term has the formula A plus n minus 1 times D. And this formula becomes the general formula of all the terms of an AP. Meaning that if you want to get any of the terms of the AP, being it first term, second term, third term, fourth term, and so on, this formula would have to come to play before you can get all the terms in an AP. So for that matter, this formula UN is equal to A plus n minus 1 into bracket times D has these parameters or these variables in them, where the variable A stands for the first term, where the variable n is the number of terms. That means the variable n stands for how many terms are in the sequence. That is the number of terms, or the position of the term. That is to say, if the term is the first term, the second term, the third term, the fourth term, fifth term, and so on. That is where n is. So to get the terms, let's start from the first term. The first term has a symbol of U1. You can also use T1 in place of U1. But let's go. Now, the general formula or the general term, which is the nth term, is given as A plus into bracket n minus 1 times D. Now, UN means the nth term. We want the first term, so we just give it as U1, where 1 is the position of the term. That's the first term. Now, A plus 1 minus 1, because n is 1. So 1 minus 1 times a D. And 1 minus 1 will give us 0. So we get U1 as A plus 0D, and 0D means 0 times D, which is still 0. So we get A only standing, so it means U1 is A. So in conclusion, the first term has the formula A. So the symbol A stands for the first term. Let's do that of the second term. So now let's see that of the second term. Now the second term is giving us U2. But to get our second term formula, we need to use the nth term formula or the general formula for the AP, which is UN is equal to A plus N minus 1 into bracket times D. So where N means 2, so U2, that is the second term, is equal to A plus into bracket 2 minus 1, since N is 2, all times D. And 2 minus 1 is 1. So U2 is equal to A plus 1 times D, and 1 times D is D. So the U2 formula will be A plus D. It means that when you want to get a second term, you can go ahead and use this formula in place of the general formula for the AP. So U2, or the second term of an AP, is given as a formula A plus D. That is the first term plus the common difference. We want to get a formula for the third term in the arithmetical progression. Now the general formula is UN is equal to A plus into bracket N minus 1 times D. Now, with the third term is U3. So we have 3 as N. Now U3 is equal to A plus, in place of N we put 3. So 3 minus 1 times D. And 3 minus 1 is 2. So it becomes A plus 2D. So the U3 or the third term formula for the AP will be A plus 2D. Meaning that if you ask to find the third term and you use this formula, you will get the answer instead of the general formula for the AP. Also, the fourth term can be given as U4. Now we get the general formula UN is equal to A plus N minus 1 times D. Wherever we see N, we call it 4 because we're talking about the fourth term. And the position of the term is number 4. So N is 4. So A plus 4 minus 1, where N is 4, times D. And 4 minus 1 is 3. So we get U4 is equal to A plus 3 times D, which is 3D. So finally, the fourth term's formula will be A plus 3D. Now, that means that there is a particular process going on here. Study it very well. There's a particular pattern going on for all the sequences. So if I want to find U7, that is a seventh term, I can boldly say that I'll subtract 1 from the number of terms, which is 7, and that will become the coefficient of the D, since all the terms have AD in it. So A will be my first term plus this 7 minus 1 will turn into 6, so 6D. So that will be the formula for the 7th term. And I can even do it for the 100th term. So U100 becomes the 100th term is equal to A plus the coefficient of the D will be 100 minus 1, which is 99. We'll get 99D. So you can do this for all terms under the AP without even using the general formula or the nth term for the AP. So please take note of this. This is just for a particular term. Remember, first term, second term, third term, 100th term, 50th term, 20th term. This is for a particular term. So this formula UN is equal to A plus N minus 1 times D, that is the nth term formula, is always used when you want to find a particular term of a sequence in the AP form or the linear sequence form. Let us take an illustrative example to help you understand what we are trying to say. Now, we want to consider other formula for the arithmetical progression aside the nth term. Now, this is what I want you to take note of. In an arithmetical progression, the last term of the sequence is still having the same formula as the nth term. So this is what I'm trying to say. The nth term of a sequence is still the last term for the arithmetical progression. Meaning UN is equal to L, which is a symbol for the last term. So the UN formula and the L formula are the same, which is A plus N minus 1 times D. So in conclusion, the last term of the arithmetical progression is also equal to the first term plus N minus 1 into bracket times D. So the nth term formula is the same as the last term formula in an arithmetical progression. Now let's go to the common difference. The formula for finding the common difference in a given arithmetical progression is D is equal to the second term minus the first term. That is U2 minus U1. Or the common difference D is equal to the third term minus the second term, or U3 minus U2. Finally, or you can talk about another formula, D is equal to the fourth term minus the third term, that is U4 minus U3. So all these formula will give you the same value for D, and that is why D has different formula. And don't forget, any of these formula can be used depending on what term is present in the sequence. So if you want to find any of these formula can be used. Now in this question it reads, find the 13th term of the arithmetical progression of the form 5, 9, 13, 17 and so on. Now with this sequence we want the 13th term. So 13th term, which has the symbol U13, and then we know that UN is equal to A plus N minus 1 times D. So with this we can get a 13th term. So we will have to then do the substitution. But the first term is equal to 5. In the sequence, the first term is 5. And then we can get the common difference. The common difference is U2 minus U1. Then the common difference will become, the second term is 9 minus the first term, which is 5. So our common difference becomes 4. With the help of this, let us substitute it into the general formula. So UN, which is U13, where N is 13. So A is 5, then plus N minus 1. So 13 minus 1 times D, which is 4. Now we get U13 is equal to 5 plus 13 minus 1 is 12. So 12 times 4. Now we get U13, that is the 13th term, is equal to 5 plus. Now 12 times 4 will give us 48 on the calculator. Now 48 plus 5 will give us 53. So U13 is equal to 53. So it means therefore the 13th term of the sequence is 53. Means if you're able to go through the sequence to get to the 13th term, you realize that you end up getting 53 on the term number 13 or the 13th term. So this is the procedure for getting a certain term. In this case, is 13th term of a sequence. Just draw the whole sequence again, go through the general formula, get the value of A, the value of D, which can be found in the sequence, do the substitution into the general formula, and make U13 the subject to get 53. So that is how we do it. Please take notes and then go through it well. Just calm down, go through every single step as its own explanation. Get to understand every single step and use it to apply in other questions to get the understanding, to solve, to get the answers. Thank you. Now in this question, it reads, given the arithmetic progression 4 whole number 1 over 2, 5 whole number 1 over 2, 6 whole number 1 over 2, and so on. This find the 10th term of the sequence. Now you're supposed to find the 10th term of this sequence. Now, because of the 10th term, we have the symbol for the 10th term as U10. And since we are finding a certain term called the 10th term, we need the nth term or the general formula for the term to be able to extract that of the 10th term. So we say UN is equal to A plus N minus 1 times D. Since we are looking for the 10th term, we become U10 is equal to A plus 10 minus 1 times D. Because N is 10. That is why we have 10 minus 1. So U10 will be equal to A plus 10 minus 1 is 9D. So this is the formula for the 10th term of the sequence. But we need the number, or we need the term's number. So let's go and then look at the parameters for A and D. Now with A, we have A is equal to 4 whole number 1 over 2 as the first term. Now A is the first term, and the first term of the sequence is 4 whole number 1 over 2. Now our common difference, which is D, will be equal to U2 minus U1. So D will be equal to the second term, which is 5 whole number 1 over 2, minus the first term, which is 4 whole number 1 over 2. Now to solve, we have to break this down into improper fraction. Now we have D is equal to 2 times 5, which is 10, plus 1, making 11 over 2, minus 2 times 4, which is 8, plus 1, making 9 over 2. 11 over 2 minus 9 over 2 equals 1. Then the common difference is 1. So let's do the substitution. Now U10 has a formula of A plus 9D. So U10 is equal to our A is 4 whole number 1 over 2, then plus the common difference is 1. So 9 times D is 9 times 1. Says D is 1. Now it becomes U10 is equal to 4 whole number 1 over 2 plus 9. Let's convert this into improper fraction. Making U10 is equal to 2 times 4 is 8 plus 1. So 9 over 2 plus 9. So U10 will be equal to, now 9 over 2 plus 9 will give us 27 over 2. And 27 over 2 in the mixed fraction form will also be 13 whole number 1 over 2. So therefore, the 10th term is 13 whole number 1 over 2. So that is the answer for this particular question. Thank you. To find the number of terms in an AP. So you see, in the first place, we found the AP itself. That is a certain term of the AP. Now we want to find the number of terms in an AP. Now, number of terms have the symbol n in the AP. Now you realize that the UN has a formula a plus n minus 1 times d. That is the nth term or the general formula for the AP. Now within this, we have the n, where n is the number of term or the position of the term. With this, we can make n the subject. That is when we get the number of term. But we can also say that the last term is equal to the UN or the nth term. So since the last term is equal to the nth term, then the last term will be equal to a plus n minus 1 times d. So we can conclude that last term is equal to a plus n minus 1 times d. Now looking at this, it means that if we want to make n, which is the number of terms, the subject, we must be able to get the last term of the sequence. And getting the last term, getting the first term, getting the common difference of the sequence, we can do change of subject to make n the formula. So in conclusion, if you want to find the number of terms of a sequence, specifically the AP, arithmetic progression, or the linear sequence, then you should use the last term formula, and then in the question, the last term must be given to you. Now let us take illustrative examples on this particular last term formula. Now in this question it reads, how many terms has the linear sequence -3, -8, -13, and then the omissions in the middle to -78? Now how many terms means you are finding the number of terms of the sequence. Now to use that, we always need the last term formula, which is equal to a plus n minus 1 times d, because the last term formula is the same as the nth term. Now from the sequence, the last term is -78. A is the first term, which is -3, and then the common difference, which is d, is u2 minus u1, to be just sure of it. That is the second term minus the first term, and our second term is -8 minus the first term, which is -3. So we get d as -8 plus 3, and we get d as -5. So the common difference is -5. Now making substitution into the formula, L is equal to a plus n minus 1 times d. Our L, which is the last term, is -78. It's equal to a, which is the first term, -3 plus n minus 1 times d, and d is -5. Let us just expand to remove the brackets first of all. So -78 is equal to -3, and then -5 times n will be -5n. -5 times -1 will be +5. Then we do the grouping of like terms. Now -78, -3 will cross to the other side to be +3. Then +5 also cross to be -5 is equal to -5n. Now let us simplify this side. That is the left hand side. -78 plus 3 minus 5 will give us -80 is equal to -5n. Now we divide both sides by -5. So -80 is equal to -5n or -5n. So divided by -5, divided by -5. -5 will cancel -5, giving us 1. Now -5 into 80, so 80 divided by -5, the negative will cancel the negative, giving me 16. 5 here 1, 5 into 18, 16. So we get 16 is equal to n. So n is 16. So therefore there are 16 terms in the sequence. So there are 16 terms in the sequence. So the 16 terms represent the number of terms in the sequence. So our answer is 16. This question reads, find the number of terms in the linear sequence 3, 7, 11 up to 31. Now, we will use the last term formula, which is equal to a plus n minus 1 times d. The reason is very simple. This sequence gives us the last term, and with the help of the last term, we can make the number of terms the subject, which is n. So the change of subject will work with only the last term formula when you are asked to find the number of terms. So in conclusion, if you are asked to find the number of terms in a sequence, please use the last term formula and do your substitution. Now the last term in the sequence is 31. Now the a, which is the first term, is also 3 from the sequence. Then the d becomes our common difference, which u2 minus u1. the second term minus the first term. So D will be equal to second term, which is 7, minus this, minus the first term, which is 3. So 7 minus 3 gives us 4. So the common difference is 4. Now with the help of that, let's fix it into the last term formula. Last term is A plus N minus 1 times D. So with the times D, we go L is 31. The last term is 31. The first term is 3. Then N minus 1. And then the D common difference is 4. We are making N a subject, so we don't replace it with anything. We leave the variable N. So we expand to remove the bracket. So 31 is equal to 3 plus 4 times N is 4N. Then 4 times negative 1 becomes negative 4. Now group all like terms. That is to say, group the constants to the left-hand side. So 31, the constant 3 crosses to become minus 3, and the constant negative 4 crosses the constant to become plus 4, which is equal to 4n. That is the n value. Now, once you have group like terms, let us simplify at that side. We have 31 minus 3 plus 4 will give us 32. Is equal to 4n. So we divide both sides by 4 to make n the subject. Divide here by 4, divide here by 4. So we get 32 divided by 4 to give us 8. So we have 8 is equal to n. Over here, the 4 will cancel each other to give you 1, remaining with n. So we have therefore the n is 8. So number of terms is 8. So there are 8 terms in the sequence. So the answer for this question, finding the number of terms, is 8. Thank you. Now this question reads, find the number of terms in the arithmetic progression 11, 15, 19, and then we have the last one as 43. So if you check this, from this we can use the formula L is equal to A plus N minus 1 times D. That is the last term formula, where L is the last term. Now from the question, our last term is 43. Then we have the A as the first term, 11. Then the common difference, which is the U2 minus U1. So common difference, the second term, which is 15 minus 11. Now the common difference will be 4 at the end of the day. Now using this, let's make substitutions into the formula. So L, the last term, is equal to the first term plus N minus 1 times the common difference, where N is the number of terms. So the number of terms will show what we are looking for, or the subject for the whole formula is supposed to be N, or the number of terms. So let us now make the substitution. L is 43. A is giving us 11 plus N is unknown because that is what we are supposed to find. Minus the 1 is there, and the common difference is 4. Now let's expand the bracket. We expand to remove the bracket. So 43 is equal to 11 plus 4 times n is 4n. 4 times negative 1 is negative 4. Let us change subject to make n the subject. So it becomes 43. Now we take all the constants to the left-hand side to join the 43. So we take positive 11, crossing the equal sign to be minus 11. The negative 4 is a constant. Crossing the equal sign to the left-hand side becomes positive 4, equal to 4n, which has a variable n. Now we subtract these ones, and then we make n the subject. 43 minus 11 plus 4 should give us 36. It's equal to 4n. Then we have to divide both sides by n. So 36 is equal to 4n. Divide here by 4, then you divide here by 4. 4 will cancel itself 1 and cancel this 4 here 1, remaining with n. Now 4 goes here 1 and then goes into 36. That gives us 9. So we end up getting, therefore, the value of n is 9. So there are 9 terms in the sequence from 11 to 43. So therefore, there are 9 terms in the sequence, in the AP. So you can use AP or the linear sequence or the arithmetic sequence. That means if you are supposed to get the rest of the sequence omitted along the line, and then you count the number of terms from 11 to 43, you should get 9 terms. So the value of n is 9. That means the number of terms of this AP is 9. Thank you. We want to take a look at finding the sum of the arithmetic progression, also known as AP, also known as linear sequence. Now, the sum of an arithmetic progression refers to the sum total of all the terms in the sequence. Now, it means that when you are adding the terms in the sequence, it becomes what we call sum of the sequence. So anytime you are given a sequence and then you're able to know the first and last term of the sequence, and you add all the terms in the sequence to the last term, that character or that behavior is referred to as the sum of the terms in the sequence. Now, the sum of the terms in the sequence is given by the symbol Sn. So if you want to sum all of them, then we have a formula that we can show you. Therefore, the sum of the first n terms of the arithmetic progression or the linear sequence is given by the formula. Now, Sn is equal to the number of terms, which is n divided by 2, multiplying the first term, which is a, plus the last term l. Now, this is the first formula for the sum of the sequence. In this formula, Sn represents the sum of a certain number of terms. So this one is open to any number of terms for the meantime because it's a general formula. Now, it's equal to the number of terms divided by 2, multiplying the first term, which is a, plus the last term, which is l. So all the terms have been defined in there. N is number of terms, a is first term, and l is last term. Now, we also know that the last term has its own formula as a plus n minus 1 times d. That is the common difference. So the last term has the same formula as the nth term. So we can substitute the last term into this formula to get another formula. So Sn will be equal to the n over 2 multiplied by a plus the last term. So instead of last term, we will then put the formula for last term, which is here. So this formula for the last term we substituted in place of the last term, making a plus n minus 1 times d. So to simplify the terms in the bracket, it becomes the sum of the terms or sum of the nth term or sum of a certain number of terms will be equal to n over 2 into bracket. A plus a is 2a plus n minus 1 multiplied by d. So this becomes the second formula for Sn. That is the sum of the terms. So you can use the formula number 2 or you can use the formula number 1 depending on how the question has given you or depending on how they give the question. Now, if the question is given such that you can find the last term and you can get the first term, then you can find the sum of a certain number of terms with this first formula. But if the question gives you the common difference and it still gives you the first term, then this is where you can rely on this second formula with the common difference and the first term in there to get a sum of a certain number of terms. So these two formulas are used based on the given things or the parameters given in the question. So take note of it. What are you given in the question, or what do you have in the question that you can use to find your sum? And that is what is going to point out the formula you use in the sum. In this question, it reads, given the AP 1357 and the last term as 51, find the sum of the first 10 terms in the sequence. Now, this is an illustrative example for finding the sum of an arithmetic progression. So with this, let us solve and see how it is done. Now, the AP is 1357, omissions in the middle, to 51. Now, we have been given the first term as 1. We have been given the last term as 51. So then with this, we can use the formula for sum. So sum of the AP, which is sum of the nth term of the AP, is equal to n over 2 multiplying the first term plus the last term. So this is the formula we can use. The question is asking us to find the sum of the first 10 terms. So S10, where n is 10. So it becomes 10 over 2. Our A is 1 plus the L is 51. So then we simplify. So S10 is equal to 10 divided by 2 is 5. And then 51 plus 1 or 1 plus 51 is 52. So multiply 5 by 52. So 5 times 52 will give us 260. So S10 will be equal to 260. So therefore the sum of the first 10 terms is 260. So if you know the 10 terms in this particular sequence and then you sum all the 10 terms, you are supposed to get 260. Thank you very much. Now,